correct? You see the unit, Simon centimeter square per mole. This is for lambda m, right? What happened to lambda m value? Increasing. This is kappa, Simon per centimeter or Simon per meter. Kappa, no? What happened to kappa value? Observe kappa value. Increase. Right? So lambda m increases, whereas kappa decreases. Correct? This is what from NCERT table given. Correct? Say something. Now come back to this. What we have discussed in class. On dilution, we are talking about strong electrolyte. Strong electrolyte. On dilution, what happens to conductance or molar conductance? Increases. Conductivity kappa decreases. Same thing or not? So with the data, experimental data, we are saying it, right? So we have seen this from NCERT table. We have seen the data. Clear? Next one. So how the graph will be? If you plot a graph, that graph also we have discussed. In case of strong electrolyte, how the graph will be? How the graph will be, man? Rectangle hyperbola. We have seen that graph as lambda m versus root c, strong electrolyte. As concentration is decreasing, lambda m is increasing. So how the graph will be? Slope should be negative. If I extra plot this, it will touch y-axis, correct? What this indicates? Molar, limiting molar conductance, lambda m naught. Or we write as lambda m infinite. So what is the relation between lambda m and root c? Lambda m is equal to lambda m naught minus a plus b lambda m naught into root c. What, sir? Already we have seen. A plus b lambda m naught root c. Correct or not? Is it obeying or not? Already we have seen that equation in case of strong electrolytes. Correct? Now we are seeing another table. Now, whether we discuss about this one, what is this? Winston's bridge used to measure resistance of conductivity cell. Correct? All this data already done. Variation of conductivity and molar conductivity with concentration means on increasing concentration or decreasing concentration. Already we discussed this point. Now here one table should be there. This graph also we have seen. Seen or not? If it is weak electrolyte, almost you will get a rectangular hyperbola almost parallel to y-axis. If it is a strong electrolyte, straight line, when it touches y-axis, that is lambda m naught. Right? Now observe this. Lambda limiting molar conductivity of some ions in water. Right? Second table. Means all these are lambda naught values. Lambda naught values of different ions. So under note 0.2. Another table from NCERT. See this table? Observe the values. H plus among cations. Lambda m naught values among cations, which is having higher value among all cations. H plus Check. Among all of them, which is having higher value? H plus or not? Why H plus ion will have more conductance? If you remember, we discussed this idea. Where we discussed it. What we call that effect as? Groth's effect. Correct. Due to Groth's effect, conductance of H plus ions will be always very high. That's why Kolb's electrolysis. At cathode, H plus ions go towards cathode and H2 gas gets liberated. Right? Generally, what happens in case of any ion, any cation, if cation is small in size, Li plus aqueous, Na plus aqueous, in S block also we have discussed it. K plus aqueous. Among them, among Li plus, Na plus, K plus, which is larger in size? Lithium, among lithium, sodium, potassium, rubidium, cesium, francium. Down the group, what happens to atomic size? Online. What happens, sir? Atomic size down the group increases.
Increases.
Right? So down the group as size is increasing means, right? Number of water molecules surrounding it will increase or decrease. Why? If size increases, what happens to surface area? Then number of water molecules surrounding it will be high. Common sense, correct? But that is only first layer of water molecules. Correct? If size is small, why size of any ion will be small? If a nucleus is pulling electrons strongly, then only size will be lost, small. Right? For example, Li plus or H plus, etc. They are smaller in size. Then what happens to the surface area? Less. Then how many water molecules will surround it? Less number of water molecules only. So around Li plus, how many water molecules can surround means only 4. Around cesium plus, rubidium plus, how many means? 8. Around potassium and sodium, up to 6. Right? Now, around Li plus, only 4 water molecules are surrounding. That is in first layer. Same way in next layer, again few more water molecules. In next layer again, few more water molecules. Because what is the size of lithium? Smaller. Lithium ion size is small means nucleus is pulling electrons strongly. If lithium is able to pull electrons strongly means nuclear force is high. So it can pull the electrons of water also, no? Right? So water molecules are pulled. Next layer of water molecules also pulled. Next layer of water molecules also pulled. So what happens to total number of layers? More. Such number of layers will be less in case of cesium. No doubt cesium size is big. But why cesium size is more? Its nucleus is not able to pull its own electrons. That's why size is more. Right? If it is not able to pull its own electrons means it cannot pull the electrons from water. Therefore, you cannot have more layers of water. You will have only hardly one layer of water. Is it clear? You cannot have more layers of water. Now, if you take both into consideration, total number of water molecules, where number of water molecules surrounding an ion is high. Lithium, no? So that's why smaller the size of cation, more will be the degree of solvation. Means more will be the number of water molecules or solvent molecules surrounding it. Clear? Smaller the size of ion, cation, higher the number of water molecules surrounded. If more water molecules surround, we call it as a degree of hydration is high. Means more energy is released. That's why we call it as enthalpy of hydration is high. Clear? So hydration is high, or simply I will say solvation is high. Correct? Enthalpy of hydration is also high. Clear? So I am writing that point as size of cation decreases as size of cation decreases, what happens? Degree of solvation means number of solvent molecules surrounding it. What happens? Degree of solvation increases. That is, enthalpy of solvation will be more negative. Accepted? And when two molecules attract each other, heat energy will be released. If more water molecules or more solvent molecules are surrounding ion, means more energy will be released. Clear? Any questions in it? If more molecules are surrounding a cation, what is its ability to move towards any cathode? Can it move easily or it can't? Means that is enthalpy of solvation is more negative. And what about its ionic mobility? Right? Less ionic mobility. Correct? So ionic mobility decreases. Therefore, what happens to electrical conductance? Electrical conductance decreases. Right? Means among Li plus when surrounded by water, aqueous. The meaning of I am not writing Li plus, I am writing Li plus aqueous. Means lithium along with water molecules surrounding it. Right? Li plus aqueous, Na plus aqueous, A plus aqueous, lithium, sodium, potassium, rubidium, cesium. Now tell me, among them, which ion is having larger size, including water molecules? Including water molecules. Lithium, larger in size. And first layer, second layer, third layer, na? If I don't consider water molecules surrounding it, cesium will be larger in size, including water molecules, lithium will be larger in size. Among them, which will move towards cathode readily? Cesium. Because less water, less luggage, more comfort. Correct now? So cesium plus will move towards cathode readily. So electrical conductance of cesium plus will be high. Accepted? This is their respective electrical conductance. Now compare Na plus and K plus. Compare Na plus K plus. Compare, sir. Whether this is accepted with the data given, statement given. Acceptable? Right? No. Now the problem is with H plus ion. Now the problem is with H plus ion. H plus size is even smaller than Li plus. Then its mobility must be low. Correct? Therefore, electrical conductance must be low. Correct? So when you compare Na plus and K plus, Na plus mobility is less because its size is small. Same way, H plus size is even smaller than Na plus. So it should be even smaller. But observe the value. Its value is higher. Reason? No. H plus is surrounded by water like this. Right? Actually, H plus will not move towards cathode. What this H plus do? It will form a bond here, breaks this bond and forms H plus. What happened? H plus has migrated automatically or not? So instead of making H plus ion to move, what H plus ion will do? It will create another H plus in the next position. That will create another H plus in the next position. So indirectly, what is happening? Indirectly, it is moving. We call that effect as Grothus effect. So due to that Grothus effect, conductance of H plus is higher than expected. Is it clear? Any questions in it? So I am writing that point. Very, very, very important point, sir. Conductance of H plus is far higher than remaining all. Reason for this is Grothus effect. After H plus, which is having larger, which is having more conductance, calcium plus 2 greater than Mg plus 2 greater than K plus greater than Na plus. Respond, sir. Clear? Any questions in it? Mg plus 2, calcium plus 2. Beryllium, magnesium, calcium. Compared to magnesium, what happens to size of calcium? More. If size is more, what happens? Degree of hydration will be less. So electrical conductance will be high. Clear? Any questions in it? Now coming to anions, sir. This is about cations. This is about cations. In that cations, there is one special case, that is H plus. Reason for this H plus is Groth's effect, which we have already discussed. Now come to anion, sir. Yes, ma'am.
Sir, can you explain why ionic mobility decreases?
Why ionic mobility is low, man? Due to hydration. When more water molecules surrounded, water molecules will not allow any ion to move because of interactions. If that ion is moving, along with that ion, water also has to move, no? Right? Respond. No response. Right? Come to anions, sir. Among anions, which is having more conductance? Observe carefully. OH minus, right? So OH minus is greater than SO4 2 minus. Lowest is acetate ion, correct? I'll say something. SO4 2 minus. After that, Br minus, Cl minus, CH3COO minus. This is among anions. This is among cations. Both are about molar conductance at infinite dilution. This is second table. Now coming back. So there is one more table, man. Copper oxide, insulators. Wait, it is not there. Are we checking it from the beginning? This table is different. This one. Harder table, sir. Observe this carefully. Another table. Table number 3. Under note, table number 3. We discussed about metallic conductors and electrolytic conductors, correct? On increasing temperature, what happens to conductance of metallic conductors? Decreases due to metal kernel vibrations, right? Correct or not? Among metals, observe, which is having more electrical conductance. All these are metals only. Of course, graphite is a non-metal, but in case of graphite also electrical conductance will be there due to movement of electrons within the layer, not between the layers, within the layer, correct? Already we discussed this point in 4th group elements. So among metals, observe electrical conductance. These values are wrong. Oh, 10 cubes are missing, huh? Huh? Okay, no issue. So what is this? Simon per meter means kappa value. So kappa, conductivity of, check. Among sodium, copper, silver, gold, iron, graphite, which is having highest value? Silver. So conductivity of silver greater than, copper greater than, gold greater than, silver, copper, gold, sodium, sodium greater than, then graphite, no, iron, iron greater than graphite. Response, sir. Say something. Correct? So anyhow, that values, let me write at some place. Silver value 6.2 into 10 power 3. Copper 5.9 into 10 power 3. Gold 4.5 into 10 power 3. Sodium 2.1 into 10 power 3. Iron 10 power 3. Graphite. Hey, graphite is more than iron, na? Ah, no, no. What about graphite? 12. Correct, sir. All are in Simon per meter. Kappa values. So which is having highest metallic conductance or conductivity? Silver. After silver, copper. Silver is costlier. That's why in electrical wires, what we are using? Copper. It is cheaper and having high electrical conductance. That's why most of our electronic devices, home electrical devices, all are connected through copper wires. Clear? Next, sir. Insulators. So insulators, they have given two insulators. Glass is given now. Teflon and glass. Teflon and glass. These are the two insulators given. Teflon conductivity 10 power minus 16. Glass 10 power minus 18. Simon per meter. Simon per meter. Then semiconductors. What are semiconductors? What are semiconductors? Hey, semiconductors, man. Already we discussed about conduction band, valency band. If a gap, energy gap between conduction band and valency band is high, insulators. Moderate.
Sir,
Semiconductors. Yes, sir.
sir, for glass only 10 to the power minus 16 knows.
Oh, I changed, huh? Right. I modified it, huh? Okay. 10 power minus 18 here, minus 16 here. Right. Now come to this. Semiconductors. What happens to energy gap? Between conduction band and valency band, energy gap is moderate. If they overlap, then they are called as metallic conductors. If they overlap completely, superconductors. Already we discussed it, right? Hey, in class 11th over, in physics also it is over, in class 10th also over. PNP, NPN, diodes, transistors. What? No, very good then. Then no need to discuss. Huh? See this man. Here I am considering lithium. Electronic configuration 1s2, 2s1. Right? So this is called valency shell. If I take a lithium rod, every lithium having electrons in valency shell, all those valency shells put together for all lithium atoms, all that valency shells put together, we call it as valency band. What we call it as valency band, because in lithium rod, all lithium atoms are arranged systematically, correct or not? In a regular way, correct? Now, every lithium is trying to lose electron. From where it tries to lose electron? When it loses electron, that electron goes into this gap, correct? Response, say something. Due to mobility of these electrons, metals show electrical conductance, right? So, in order to make this electron to move from one place to another place, the electron of this valency shell has to go to another valency shell or to another energy level. From one energy level, it has to jump to another energy level, right? Means in order to make this electron to migrate, I need to increase its energy. If electron's energy rises, it has to move from valency band to some other band. We call that as conduction band. Why we call it as conduction band? If that electron is moving, electrical conductance is observed, right? Correct or not? So all these valence bands put together, all these valency orbitals put together, we call this as valency band. All the energy levels of those put together, we call it as conduction band. Every orbital is having some energy. All those orbitals are arranged regularly. If there are infinite atoms, all infinite atoms, valence orbitals are collectively called as one band. Same way, conduction band. If the gap between these two is low, if that gap is less, then what about the electron? Can move easily? If electron is able to move easily from valency band to conduction band, means that rod is a good electrical conductor. Is it clear? If this gap is more, then electrons cannot jump from valency bond to conduction band. Means the energy is not sufficient for electrons to move. Then what we call such metals as insulators. Clear? If that is very less, conductors, very high, insulators. If they are moderate, if the gap is not very high, not less, then what we call it as semiconductors. Means if this gap is moderate, if I give energy from outside to that electron, then what happens? This electron can jump from here to here easily. How I am going to provide that energy? By heating. Correct? That's why semiconductors on heating, they will show electrical conductance. So generally, metallic conductors on heating, what happens to electrical conductance? Decreases. But in case of semiconductors, increases. Clear? Any questions? No. Instead of heating, in place of, assume this is a semiconductor, like copper oxide or silicon or germanium. Instead of lithium, let me assume all these are silicon atoms. So it is a semiconductor, right? Now, this is valence band of silicon. Assume this as valency band of silicon. Instead of one silicon, I have kept germanium, right? Or I have kept phosphorus or arsenic, some other element. What happens to its valency band? Compared to carbon family. Before carbon family, you have boron family. Boron, aluminum, gallium, right? So instead of silicon, I have taken aluminum. Instead of one silicon, I have placed one aluminum there, right? In a period from left to right, what happens to size? Decreases, correct? Huh? Now, what about size of aluminum? Larger than silicon. Means what happens to energy? Size of atom is more means that orbital moves away from nucleus. Orbital is moving away from the nucleus means what happens to its energy? High. Means all silicon atoms valency band is this much, but because of this aluminum, you will have one more valency band somewhere here. That is because of aluminum. Correct? Are you able to understand? Now, observe this electron. If I give energy, then only electron can jump from here to here. But now what I have made? I have created a bridge in between. If you apply voltage, electron can jump from here to here. From here to here, it can jump. Is it clear? Right? Now, what happens to electrical conductance? Exist. Means, instead of providing heat energy, what we have done? We have made availability of some other element inside that regular arrangement. We call it as a doping. What we call it as doping. Instead of a regular series of elements, we replace a few positions with adjacent elements having higher valency or lower valency. Right? Is it clear? Then what happens to electrons? Electrons, that energy gap now got reduced because we have a bridge in between. We call that as doping. Right? Or adding some impurity into that metal. We increased the electrical conductance of that metal. Is it clear? Any questions? Clear? Respond, sir. No. For example, what is the valency of silicon? 4. Around silicon, 4 electrons will be there, or valence electrons. Now, if you take, this is carbon family, carbon, silicon. Now, if I take aluminum, what is the valence electrons of aluminum? 3 only. Means around aluminum only 3 are possible, but around silicon 4 are possible. Means one deficiency is there because of aluminum. Right? If a deficiency exists, neighboring electron can jump from here to that position. From here, another electron can jump into this position. Means because of the deficiency also, electrons can move easily now. Clear? So there is movement of hole or empty position. Movement of empty position. Right? Or movement of positive. Can I say it as positive? Electron is deficient means we can call it as positive. Right? So we call that as P-type semiconductor. Positive type semiconductor. Why I call it as semiconductor? Already we discussed silicon is a semiconductor or not. What we have done? By introducing some foreign material, some impurity, we are increasing the electrical conductance of it. We call that method as a doping technique. So by doping silicon with some other metal, right, either with higher valency or lower valency. If it is with lower valency, I call it as P-type semiconductor. Instead of aluminum, if you take carbon, silicon, nitrogen, phosphorus, if I dope that with phosphorus valency 5, silicon valency 4. So phosphorus has one extra electron. That extra electron can move now. Then I call that as negative semiconductor, N-type semiconductor. This is a P-type semiconductor. That is called N-type semiconductor. Means if a semiconductor was doped with lower valency element, we will create P-type semiconductors. If I dope with higher valency elements, we create N-type semiconductors. Right? If we sandwich one P-type, one N-type, another P-type, then this complete set is called diode. What type of diode it is called? PNP diode. Similarly, NPN diode. Right? Now, it is rich in electrons. It is having deficiency. it is again having rich in electrons, right? So how transistors are created? Transistors are created by using diodes. Is it clear? For further study, you study in physics. For us, diodes is sufficient. Clear? Are you able to understand? Is it clear about conductors, insulators, semiconductors? Say something. First, we have seen conductors. All these are conductors. So all these are conductors means what about energy gap between their valency band and conduction band? Very less or almost overlapping happened. Right? If that gap is high, examples, Teflon glass. Semiconductors, example, copper oxide, silicon, germanium. That's bond. Copper oxide electrical conductance 10 power minus 7. Silicon 1.5 into 10 power minus 2. Germanium 2 units. Simon per meter, Simon per meter, Simon per meter. Any questions, sir? Right? Clear or not? Now come to this another point. This part, semiconductor part, insulator part, all these three are over. Now coming to aqueous solutions. Now, among all of them, which is having lowest value of electrical conductance? Pure water. So pure water is a bad conductor of electricity. Reason? Pure water doesn't have any ions. Or at 25 degrees centigrade, how many parts of water molecules can convert into ions? From 1 liter, 10 power minus 7 moles per liter will be in ionized form, Arrhenius theory. Correct or not? That's why we write pH equal to 7 at 25 degrees centigrade. Correct? So which is negligible. Therefore, the electrical conductance is very low. If I add any salt, electrical conductance increases. Right? So that's why if you are standing under in rainy season under an electrical pole, what happens? Nothing happens. Right? Yes or no? Now keep some salt on your head. Now stand. Or throw some salt near the pole and stand. Now everything happens. No need to stand next time. Reason? You are increasing electrical conductance, man. Are you able to understand? Right? No. This is the reason electrical poles should not be kept near to oceans or near sea belt. We should not use electrical poles because it is a good conductor of electricity. Right? Now, sir, we are writing this in an order. Among them, which is having higher electrical conductance, observe. Among all of them, which is having highest value. Why? Because it is because of H plus and Cl minus. Groth's effect. H plus will show more conductance. So conductance is due to cations as well as anions. Now conductance of cation plus conductance of anions both added. Then only you will get conductance of HCl. Coulter's law. Right? So which is higher value? HCl. Now compare with the same concentration. Don't compare remaining. Among HCl and CH3COH, which is having 0.1 molar HCl having electrical conductance greater than CH3COOH. HCl value 3.91, acetic acid value 0.047. This is for 0.1 molar. Then 0.01 molar. 0.01 molar. And if you take 0.01 molar, which is higher, KCl, NaCl, already we know this. Already we know this. No need of checking this value. Cl minus is common in both. Among Na plus and K plus, which will show more conductance? K plus. That's why which should have higher value? K plus. So 0.01 molar This is aqueous. This is also aqueous. Huh? Molar KCl aqueous will have higher value than NaCl aqueous. Values 0.14, 0.12. Now, water is a poor conductor of electricity. Its conductance is 3.5 into 10 power minus 5. All these are molar conductance at infinite dilutions. Units are Simon per meter. So that complete data table of NCRT is done. Any questions in this? Without the table also already we can give compare. Only this is for one evidence. Experimental data. That's enough. Clear? So tables from NCRT is over. Right? Next. Very, very, very important point. This ionic mobility part up to 2006 we used to discuss. From 2006 they deleted everywhere. Almost from many textbooks also they have deleted. Reason? Up to 1995 they used to frame questions based upon ionic mobility. From 1995 they stopped asking questions related to that. So in books also up to 2005 2006 they used to kept in our target booklets. After they stopped asking, they waited for 10 years. After that they also started deleting it, right? But JEE advanced means expect the unexpected, right? So that's why we need to study. So let me show it first. So note 4. Ionic mobility and a transport number. These are the 2 points, sir. Ionic mobility, transport number. Just I will show and I will go back. Series. Ionic mobility. Symbol mu. Definition. Speed of ions divided by what is the voltage applied. Speed of ions divided by voltage applied is called ionic mobility, right? So speed of ions we call it as ionic velocity. No? If they move towards one direction, right? When you apply voltage, ions will move always towards that electrode only. No? They cannot move in all directions. So it becomes a directional property. So that's why instead of speed we are writing velocity. Even generally we can write speed also, no issue, right? Ionic mobility symbol mu. Definition. Define it. Ionic speed upon ionic velocity upon potential gradient. What do you mean by potential gradient here? Potential gradient. If I have applied one electrode, I kept one electrode at this end by applying some voltage, assume 10 volts. As we move away from that metal rod, what happens to its influence? Decreases, correct? So per unit centimeter, how much is the voltage changing? Right? That is called potential gradient, right? So upon potential gradient. Or we can write this as ionic velocity upon potential difference upon distance between the distance from electrode. Right? Now, conductance of any ion is equal to its ionic mobility into Faraday. What is 1 Faraday? Charge of 1 Faraday means charge of 1 mole of electrons. 6.022 into 10 power 23 into charge of each electron 1.602 into 10 power minus 19 coulomb, which is equal to 96,500 coulombs. We call it as 1 Faraday. Right? If I take 1 mole of Na plus ions, 1 mole of Na plus ions have 1 Faraday into its mobility. Used what is the net electrical conductance shown by the ion. So electrical conductance lambda equal to its mobility into what is the total charge it is transporting. Right? Now, absolute ionic mobility. Absolute ionic mobility. Online. Are you following or not?
Yes,
Following,
sir.
sir.
Right.
Yes, sir.
So absolute ionic mobility is speed of an ion in centimeter per second yet infinite dilution when there is a potential gradient of 1 volt per centimeter. This is called absolute ionic mobility. Ionic mobility and absolute ionic mobility. Next one, transport number. Transport number. Now, by applying voltage, ions are moving from one position to another position. Because of movement of these ions, there is electrical conductance, right? Then what is the fraction of current because of one ion is called transport number, right? Transport number means fraction of current carried by an ion. This transport number is also called as transference number. Now, mathematically, we can write that in this way. Transport number due to anions. Transport number due to anion. What you can write? Current carried by an anion divided by a fraction of current carried by an ion, man. So what is transport number of an anion? Current carried by an anion divided by total current, right? So current carried by an anion upon total current. Transport number of cation. Current carried by cation upon total current. If I add both, what you will get? Transport number of cation and transport number of anions. If I add both, what you will get? 1. Or it is fraction, na? If I add all fractions, what I will get? 1, na? Hey, what, sir? All these are fractions only, na? So transport number of sum of transport numbers of all ions becomes equal to 1. Right? If I am considering only 1 mole of cation, 1 mole of anions, that's all. Right? If you take only 1 cation, 1 anion, that is also same fraction only. Right? No, yes, sir. You are asking something. Divided by? Arey, what is this, man? Current carried by all anions divided by total current gives what you will get? Total number of anions only, na? That's what I quote. Transport number is nothing but transport number, na? Obviously. What, man? Clear or not? Next, sir. Ni is? Array. Again, listen. If there are different types of anions, as long as OH minus is present, see this, among all anions, which anion shows electrical conductance? If all these anions are present, which have more electrical conductance? Means current is due to only OH minus ions, no? As long as OH minus is present, current due to SO4 2 minus and CH3CO minus, Cl minus, Br minus is 0. So don't say total anions. Are you able to understand? Electrical conductance here is only because of OH minus ions. That's why we are calling it as transport number of OH minus ions only. Don't say total number of ions. Clear? No. As long as OH minus is present, remaining all will not be moving. Completely it is taken by OH minus. As long as H plus is present, conductance due to Na plus and K plus ions, everything becomes 0. Once H plus is over, if there is no H plus ions, then conductance starts showing because of. Hey, I'm talking about H plus, man. As long as H plus, if H plus ions are over, then conductance should start because of Ca plus 2. If it is also over, then Mj plus 2, then K plus, then Na plus. Are you able to understand? Based upon everything is based upon their mobility and their ability to undergo reduction. Maybe. Obviously. 1 mole. Or number of cations and anions both becomes equal is equal to 1 mole of salt. Over. Right? Response, sir. Any questions further? Online, alive or dead?
No questions, sir.
Now, point number 5. Right? 1, 2, 3, 4. Now I am talking about point number 5, sir. Under note point number 5. Now see this, sir. Degree of dissociation or degree of ionization, alpha can be written as. What we will write? Alpha, fraction. Alpha is nothing but degree, percentage ionization. How you will write? Conductance shown upon conductance at infinite dilution? What you say? Degree of dissociation alpha can be written as lambda upon lambda naught. Yes or no? Lambda naught is the maximum conductance at infinite dilution. That is the highest value possible. What is the conductance now? If I divide both, what is the fraction of ions generated? Lambda naught is when 100% ionization happened, right? Lambda is at certain percentage. Now, what is the percentage ionization? Obtained marks by maximum marks, na? Right? And obtained conductance by maximum conductance gives fraction of ions. Clear? Response, sir. Or we can also write molar conductance lambda m is equal to alpha into lambda m naught. Can I write it? Say something. Can I write this or not? Online.
Yes, sir.
What is the conductance shown now upon what is the maximum conductance possible? Gives what are the fraction of ions available now? We call it as the degree of ionization, right? Now, one more point, sir. Point number 6. I am writing molar conductance at infinite dilution for Al2SO4 thrice. According to Kohlrausch law, what I have to write? According to Kohlrausch law, or according to transport number, or according to ionic mobility, what will be the conductance I have to write? Due to cations plus anion. So, can I write 2 times of lambda naught of Al plus 3 plus 3 times of lambda naught of SO4 2 minus. Acceptable or not? Online, someone respond.
Yes, sir.
Yes,
So
sir.
I call this as molar conductance, correct? Can I write molar conductance or not? And you already know this statement. Normality equal to molarity into n factor. Normality equal to molarity into n factor. Already you know this. What is formula of equivalent conductance? Lambda EQ equal to kappa into 1000 upon normality units Simon centimeter square per equivalent. Sir, correct or not? No. Instead of this normality, can I write molarity into n factor? Instead of this normality, can I write molarity into n factor? So if I write this as molarity into n factor, bring that n factor to this side. What do you get? I am writing lambda EQ equal to kappa into 1000 upon, instead of normality, I am writing molarity into molarity into n factor. I am bringing this n factor to this side. So n factor into equivalent conductance equal to kappa into 1000 by molarity. What will we write it as? What do we write as? Lambda molar conductance, right? So what we can write? Molar conductance equal to equivalent conductance into n factor. Correct? Huh? Correct or not? So I am writing the same. Molar conductance equal to equivalent conductance into n factor. Correct? Same way here also. If I divide that molar conductance with n factor, what you will get? Divide this with its n factor, what I will get? So I am writing the same. Equivalent conductance of Al2SO4 thrice equal to what you will write? What you will write? Equivalent conductance of Al2SO4 thrice can be written as molar conductance divided by 6. Alright. So in case of salt, what is n factor? Total charge of cations or total charge of anions. Correct? So I'm writing this as lambda naught of Al2SO4 thrice upon n factor is 6. Correct, sir? Correct? Instead of this, can I substitute this term? Instead of this, can I substitute this? Right? So I am writing the same. That implies lambda of Al2SO4 thrice equal to 2 times of lambda naught of Al plus 3 upon 6 plus 3 times of lambda naught of SO4 2 minus upon 6. Correct, sir? Yes or no? Now, can I cancel? This is equal to lambda naught of Al plus 3 upon 3 plus lambda naught of SO4 2 minus upon 2. Any questions in this? Can I say this 3 is n factor of Al plus 3? And this 2 is n factor of SO4 2 minus? Correct? So lambda by n factor can be written as equivalent conductance of Al plus 3 plus equivalent conductance of SO4 2 minus is equal to equivalent conductance of Al2 SO4 thrice. Now observe these two equations carefully. This one and the first one. This one and this one carefully. What you have observed? What you observed?
While equivalent conductance, you are not considering the number of cations or anions.
While you are calculating molar conductance, you need to take number of cations and number of anions into consideration. While you are calculating equivalent conductance, we don't care how many cations present, how many anions present. Only equivalent conductance of cation plus equivalent conductance due to anion. Just if I add, you will get equivalent conductance of the salt. But when you are calculating molar conductance, you need to consider how many cations are present and how many anions are present. Clear? Any questions? Any questions? Online?
No questions, sir.
Right? No. For example, I am taking a salt AXBY. I am taking a salt AXBY. Right? So for this salt, if I want to calculate lambda naught, what I will write? I want to calculate molar conductance. What I will write? X into lambda naught of A plus Y plus Y into lambda naught of B minus X. If I want to calculate equivalent conductance of AXBY, now what I will write? Equivalent conductance of A plus Y plus equivalent conductance of B minus X. I don't care about number of cations, number of anions. Clear? Any questions, sir? Online? We have any questions in this?
No, sir.
Same thing we have studied in ionic equilibrium chapter also, if you remember, solubility product. Right, let us consider AXBY is the salt, gives XA plus Y ions plus YB minus X ions. If this salt's solubility is, if its solubility is S moles per liter, then what is concentration of A plus Y equal to. What is the concentration of A plus Y? Or if 10 moles of AXBY is soluble, then how many A plus Y you will get? 10x. Or if 1 mole is soluble, how many moles you are getting? X moles. If 10 moles soluble, 10x. If S moles soluble, right? What you will get? XS. Correct? Then what is concentration of B minus X? YS. Then what is KSP? What is KSP of it? Concentration of this power X into concentration of this power Y. Let us say something. KSP we will write as equilibrium constant, man. What do you write? Concentration of A plus Y power X into concentration of B minus X power Y. Correct? This concentration power X, this concentration power Y. What is the concentration of A power A plus Y? XS power X. Correct? So XS power X, YS power Y. So what is KSP equal to? X power X into Y power Y into S power X plus Y. Correct? Respond. Online. Correct or not?
Yes, sir.
How many times you might have studied here? CaF2 gives rise and form Ca plus 2 plus 2F minus. What is KSP? If its solubility is S, you will get S here, you will get S here. What is its KSP equal to? S into 2S power 2, 4S cube. Correct? We have seen this. So many numericals also we solved. What's that? Ionic equilibrium chapter. Go to hell then. I don't know that. Now, from this equation, what is S equal to? What is S equal to? KSP upon X power X, Y power Y, whole power 1 upon X plus Y. So X plus Y to root of this term, right? This is solubility equation, correct? Instead of solubility, can I write concentration? Instead of solubility, can I write concentration? Or moles per liter, na? Right? What is molar conductance? Formula. Better I will write as note 7. What is molar conductance formula, sir? Lambda m equal to kappa into 1000 upon what I will write? Molarity. Instead of molarity, what I am writing now? Instead of molarity, I will write KSP upon X power X into Y power Y whole power 1 upon X plus Y. Is it clear? Any questions in it? So by using this idea, ionic equilibrium chapter solubility product is linked with electrochemistry chapter. Done?
Sir.
Yes, sir.
Sir, can you explain how we substituted the value of S in the formulas?
Hey, what is molar conductance formula, sir? What is molar conductance formula? See, what is molar conductance formula? Kappa into 1000 by molarity, right? Correct? We will write
Yes, sir.
1000 as centimeter cube per mole and molarity as moles. This is centimeter cube per liter, moles per liter. Correct? The units of this is 1000 as centimeter cube per liter upon molarity as moles per liter. Correct or not? I say something. So moles per liter means nothing but solubility. What is the
Yes,
solubility
sir.
of AXBY? Yes, moles per liter, na? Right? So directly what I am doing, instead of this M moles per liter, directly I am writing solubility. Clear? Means in this equation, instead of M, what I am writing directly? Yes. Right? Correct? Already you know the equation of S. What is the equation of X? What is the equation of X? This is the equation of S. Substituting that equation of S. Over. Clear? Online? Anything else?
Clear, sir.
Right, sir. I feel every point we have done. Everything related to conductance and conductivity is done. One more part left. Conductometric titration. Sorry, check. Any other pending? Over. Only conductometric titrations part left. So last part required is conductometric titrations. Conductometric titration. This is simply a graph between conductance versus volume of electrolyte used. So it is a plot between either molar conductance or equivalent conductance versus volume of that corresponding solution. First, I am plotting a graph between titration between strong acid versus strong base. Conductometric titration in case of titrating strong acid with strong base. Right? Now what I will do? See this. This is burette having certain readings, correct? Now conical flask you will take, this is what experiments you are doing, right? So here you will take some unknown, right? Assume unknown base. Concentration is unknown, but volume equal to 20 ml. By using pipette, we will take 20 ml of that solution. We will take that in that conical flask, right? And assume this is known concentration of HCl. Let it be 1 molar. What we will do? We will add one indicator, phenolphthalein indicator, and we will add this drop by drop. Whenever you will find end point, whenever you find color change of phenolphthalein indicator from pink to colorless, in basic medium pink color, na, right? When you are adding acid drop by drop, at certain point, what happens to color of phenolphthalein indicator? Becomes colorless. At that point, you will measure the value. From there, what you will get? Volume of HCl you will get. Let the volume of HCl equal to 10 molar, 10 ml. Then what is the concentration of it? N1V1 equal to, so N1V1 equal to N2V2, correct? What is N1? 1, volume 10 equal to N2, don't know, volume 20, therefore N2 equal to 0.5. Correct? So we are calculating concentration of unknown base. Here, what is the thing which is helping us to find the equivalence point, end point? Phenolphthalein indicator. If there is no phenolphthalein indicator, I cannot stop the titration. Correct? Correct or not? Right? So this is called simple acid base titration with the help of indicator, phenolphthalein indicator. Now I will not add indicator. I will keep that conductometer. That two metal pieces 1 centimeter apart, right? Which was positive terminal, negative terminal are connected to voltmeter by using some external source, right? Clear? So I am doing this titration and I am going to calculate end point or equivalence point by measuring conductivity values or molar conductance values. Is it clear? Any questions in it? Right? Initially, what I have taken in that solution? Initially what I have taken here, base. So here I kept that conductometer, right? So now that conductometer shows electrical conductance because of Na plus ions and Cl minus ions. Sorry, Na plus ions and OH minus ions, right? Assume initially 10 Na plus ions are there, 10 OH minus ions are there. These are the ions which are responsible for that electrical conductance, right? Now from here I have added one HCl. Means what I have added? One H plus and one Cl minus. Now both will react. What you will form? What you will get? NaCl plus H2O. Correct? Means out of this 10 Na plus and 10 OH minus, or NaOH react with HCl to form NaCl plus H2O. We know that H2O is a poor conductor of electricity. It will not convert into ions easily. But this will convert into Na plus and Cl minus. Correct? Now after adding one HCl, now tell me what are the ions left? Okay, 9 Na plus, 9 OH minus plus 1 Na plus, 1 Cl minus. Correct, sir? 1 OH minus and 1 H plus is gone. Right, from this 1 OH minus 1 H plus gone as 1 H2O. Correct? Say something. Now observe what happened to total number of Na plus ions. Same. So there is no change in number of Na plus ions. So I am writing it as a 10 only. But instead of OH minus, we got 1 Cl minus. If I add another mole of HCl, now what happened? 10, 8, 2. If I keep on adding after certain point, 10 Na plus only, this is gone. Correct? Correct or not? Now, how much amount of NaOH left? At this point, how much amount of NaOH left? 0. So I have completely reacted NaOH with HCl or not? At this point. Correct or not? Say something, man. Right? Now if I add again 1 mole of HCl. Now I am adding again 1 mole of HCl. What happened? This 10 Na plus remains as 10 Na plus only. OH minus is not there. Now Cl minus ions become 11 and H plus ions become 1. If I add again HCl, this remains this only. Now it becomes. Now observe here, up to this position, what happened to total number of ions? From here to here, what happened to total number of ions? Remain same. 10 Na plus, 10 OH minus. Now it became 10 Na plus, 9 OH minus, 1 Cl minus. Correct or not? 10, 8, 2. 10, 10. What happened to total number of ions? Doesn't change. Means till you reach equivalence point, when I am titrating, till you reach equivalence point, total number of ions doesn't change. Once you cross that equivalence point, what happened to total number of ions? Correct? Huh? Changes? Increases? Then what happens to electrical conductance suddenly? Up to that point, now see here again. You are replacing OH minus ions with Cl minus ions now up to that point. Total number of ions are same. Na plus ions are constant. They are not changing. But OH minus ions are replaced by, instead of 10 OH minus, now it became 9 and 1. So each OH minus is replaced by. Now among conductance, OH minus and Cl minus, which is having better conductance? Check. Yeah, in this table. OH minus and Cl minus, which is having more conductance? OH minus shows more conductance than Cl minus. Now, if I keep on adding HCl from outside, what happens to total conductance now? Decreases. Because each OH minus is replaced by. So conductance of OH minus is more. Now net number of ions is not changing, but their respective conductance is decreasing. So what happens to overall conductance up to you reach equivalence point? After crossing this point, what happened to conductance? Suddenly there is generation of Groth's effect. What happened to conductance suddenly? Are you able to understand? So when I am titrating NaOH with HCl, till you reach equivalence point, conductance keep on decreasing. After reaching that position, suddenly it starts increasing. Wherever there is a sudden change, that point is called equivalence point. Are you able to understand? Now I am plotting a graph. Tell me how the graph exists. I am plotting a graph. Now see this. I am plotting a graph between molar conductance or equivalent conductance versus volume of HCl added from outside. Initially, what is the solution present inside the beaker? So initial conductance is because of Na plus and OH minus ion. So initially assume this is the conductance. This conductance is because of Na plus and OH minus. So that is the conductance of NaOH. Response, sir. Now I am adding HCl from outside. Right? If I add HCl from outside, what happens? Conductance keep on decreasing up to certain extent. Right? Correct or not? Any questions in it? So it keep on decreasing. After certain point, it started increasing suddenly. Why it is not detecting automatically? Right. Now tell me, sir, exactly at this point, this is the conductance due to what? This is the conductance due to what? Yes, sir. That is lambda of NaCl or not? Right? After that point means, or I can say, this is the point at which after adding this much volume of HCl, this is the equivalence point where milliequivalents of HCl became equal to milliequivalents of NaOH taken. So I call this point as equivalence point. Now, why it started increasing? Why this started increasing? Due to increase in total number of ions. Response, sir. Yes or no? Now, why this is decreasing? Why this is decreasing, sir? Why this decreases? Because OH minus ions are replaced by Cl minus ions. Conductance of OH minus ions is more than Cl minus ions. As OH minus ions are replaced by Cl minus ions, that is decreasing. Correct? Yes or no? Right? Here I am writing OH minus ions are replaced by Cl minus ions. That's why it is decreasing. Correct? Any questions? Instead of NaOH versus HCl, if I take HCl here and NaOH here, then also graph seems to be same. Then what I will write here? H plus ions are replaced by Na plus ions. That's why conductance is decreasing. After equivalence point, total conductance increases due to increase in total number of ions. Say something, right? I am plotting same graph again. Stop talking and listen carefully. Here I am titrating HCl versus NaOH. HCl versus NaOH. On y-axis, I am taking lambda m. On x-axis, I am taking volume of NaOH added from outside. Initial conductance will be very high. Reason? Due to presence of H plus, growth effect, H plus conductance will be far high. Compared to NaOH, here it will be very high. Correct? So this is because of lambda of HCl. During titration, what happens? If I am allowing these to react, there are 10 H plus, 10 Cl minus. If I add one NaOH, what happens? One NaOH react with one HCl to form NaCl plus H2O. Correct or not? So I am getting NaCl plus H2O means number of H plus ions becomes 9. Cl minus ions remain as 10 only. One Na plus. Correct? Yes or no? Any questions in it? If I keep on doing it, H plus ions slowly replaced by, after all H plus ions are over, whatever NaOH you are adding. Right here, this becomes 0, this becomes 10 Cl minus, this becomes 10 Na plus. Now if I add again one NaOH, 10 remains this only. Now it becomes 11 Na plus and 1 OH minus. Now total number of ions. Therefore, conductance started increasing. Clear? Any questions in it? So first the conductance keep on decreasing. After reaching equivalence point, again it starts increasing. Why there is increase here? Why there is increase here? Due to increase in number of ions. Why there is decrease here? H plus replaced by Na plus. Correct? Say something. And what about this point? Equivalence point, where milliequivalents of HCl equal to milliequivalents of NaOH. What about this point? What is this point? Of NaCl. Correct, sir? Say something, man. Correct or not? This is during titration of strong acid versus strong base. Now I am titrating weak acid with strong base. Point number 2. Titration of weak acid versus strong base. I am taking acetic acid as weak acid, NaOH as a strong base. I am doing this titration again. In the same way, I am plotting a graph. So assume this is lambda m, and I am using NaOH. So volume of NaOH added in ml. Now, initially, what is present inside that conical flask? Initial conductance is because of. See the graph carefully. Weak acid, right? So initial conductance is because of CH3COH. It will not ionize completely, right? It shows only partial ionization, correct? Due to partial ionization, less number of anions and less number of cations are available. So conductance will be low, not like this. So it will be low. Somewhere I can write that point here, less value, not higher, lower. Assume this is the lower value. Now, initially there are some free H plus ions available. Because of that free H plus ions, it shows some conductance. Now, from outside, if I add NaOH, what happens? This OH minus first removes this H plus. Correct? If OH minus removes that H plus, converts into H2O, what is left? CH3CO minus and among H plus and Na plus, which is having better conductance. So initially what happens to conductance? Decrease. Reason, free H plus ions are replaced by Na plus. Therefore, conductance decreases initially. Now, conductance decreased. Right? After removing this free H plus ions, after that removing that free H plus, now there are no free H plus ions. Right? Free H plus ions are not there, but acetic acid is there. CH3CO minus is there. Na plus is there. Correct? Response, sir. Assume this is 1, this is 1, this is 9 out of 10. Right? Now I am adding NaOH out from outside. Another mole of NaOH. Now what happens? This NaOH will react with CH3COH to form. NaOH react with CH3COOH to form CH3COONA plus H2O. This salt which can convert into ions readily. Correct? Now what you will have? You will have 2 moles of CH3CO minus, 2 moles of Na plus, and 8 moles of acetic acid. Now compared to this, what happened to total number of ions? Increased, no? So what happens to conductance now? Are you able to understand? Initially, why there is decrease? Initially, some free H plus ions are available because acetic acid ionizes partial. When it ionizes partially, little H plus is there, right? When you are adding NaOH, that little H plus is replaced by Na plus. That's why conductance decreased in initial. After that, when you are adding, total number of ions are increasing, right? Due to ionization of CH3COONA, conductance started increasing. So up to here it started decreasing. After a certain point, it started increasing. Right? Now, after that, it started increasing. Now all this acetic acid got reacted. Not there. You got a 10. You got a 10. Correct? Complete titration is done. Now I am adding NaOH again. Second, another mole of NaOH. Then what happens to total number of Na plus? 11. CH3CO minus 10 only. OH minus 1. What happens to conductance? Up to this extent, due to ionization of CH3COONA, conductance keep on increasing. After reaching this point, compared to CH3CO minus, conductance of OH minus is high. Correct? Number of CH3CO minus are 11, 10 only. Na plus ions are 11, OH minus ions are 1. What happened to total number of ions? Total number of ions increase, therefore conductance has to increase further. And also conductance of OH minus is greater than acetic acid. So increase in slope is more, right? So initially, if there is an increase like this, after reaching equivalence point, what happened? It increases rapidly. Is it clear? So I call this point as equivalence point. Now, why there is sudden increase here? Due to increase in total number of ions, right? So due to increase in total number of ions. Now, what about this point? What about this point? Initially, there is a decrease. Why this change is there initially? Why this change is there initially? Reason? Free H plus ions are replaced by Na plus, right? Response, sir. So free H plus ions are replaced. Now, why there is increase here? Why there is increase? Why it started increasing here? Instead of unionized CH3COOH, we are getting ionizable CH3CO minus. That is one CH3COH is converting to CH3CONA, na? Right? So CH3COOH is replaced by CH3COONA. Correct or not? Any questions? Or say something online. No one is responding. Understandable or not?
Yes, sir.
So this is about titration of weak acid versus strong base. Same way, weak base versus strong acid. Similar graph. So I am not going to draw it again. Next one, sir. I am taking one more example. Titration of AgNO3 aqueous with KCl aqueous. AgNO3 aqueous versus KCl aqueous. So this is lambda versus volume of KCl added. Right. So initial conductance is because of Ag plus and NO3 minus. Right? On adding KCl, AgNO3 react with KCl to form AgCl, precipitate insoluble in water, plus KNO3. Right? Initially, what are the ions available? Ag plus NO3 minus. Now, what are the ions available? K plus NO3 minus. Right? Clear, sir? Among what about NO3 minus ions? NO3 minus ions are common. So, what happened indirectly? Ag plus is replaced by K plus. Or initially, one Ag plus is there, one AgNO3 converted into one KNO3. Correct? So, initial conductance is because of Ag plus and NO3 minus ions. Now, conductance is because of K plus and NO3 minus. NO3 minus is common only in both. What happened in total? What is the change? Ag plus is replaced by K plus. Conductance of K plus is more than Ag plus. So, during titration, what happens to conductance? Increases, but of course not much difference, little difference. Therefore, what happens to conductance? AgNO3 is a good electrolyte. So initial conductance is high. So compared to Ag plus, K plus conductance is more. So why there is increase in conductance? Because Ag plus aqueous is replaced by K plus aqueous. That's why you will find increase in conductance. After reaching equivalence point, if I keep on adding KCl again and again, what happened? Total number of ions increases. Therefore, conductance. Why this is observed? Due to increase in total number of ions. And this is due to lambda of AgNO3. What about this point? This point is equivalence point. Is it clear, sir? Right? So compared to volumetric titrations by using burette, pipette, and so on, conductometric titrations gives more accurate value. Clear? Are you able to understand this term? Any questions in it? Same way, potentiometric titrations. Here we are measuring conductance. In potentiometric titration, we will measure potential difference. There also we will plot graphs in the same way. Right? K plus is better than, it is not silver metal, silver ion, Ag plus ion, K plus ion. Correct? Any questions, sir, further? We have any questions further? Now open your target booklets. Yes, sir. KCl versus AgNO3, yeah? ABR. Almost straight line they might have given, but actually it has to increase a little, right? Now, sir, please stop talking. Once open your target booklets, go to page number. Let me open the booklet. 12th electrochemistry. Yes. Electrochemistry booklet. In this, listen. Already we have solved these 5 questions. Kohlrausch law over. Applications of Kohlrausch law. Check, sir. Done or not? Say something. This value, sir. See. Equilibrium constant. We are calculating equilibrium constant. Okay. Let me discuss that also as a note. We will discuss that point. What is acetic acid? Acetic acid is a weak electrolyte. So CH3CO minus aqueous gives rise and form CH3COO minus plus H plus. Initially at time t equal to 0, let its concentration be C. When time t equal to T equilibrium, C minus C alpha, C alpha, C alpha. Where alpha is degree of, right, ionization, correct? Because it is forming ions, no? That's why I call it as ionization. Then what is equilibrium constant? K equilibrium equal to, or can I call it as Ka? Acid, na? So Ka equal to, what you will write? Concentration of CH3CO minus into concentration of H plus upon concentration of CH3COOH. What is concentration of CH3CO minus? C alpha upon C into 1 minus alpha. So what do you write? Ka equal to C alpha square upon 1 minus alpha. Correct? Correct or not? C alpha upon C into 1 minus alpha, man. Correct? No. Already we know alpha is equal to lambda by lambda naught. The degree of dissociation alpha equal to, already we have seen na, lambda by lambda naught. Right? Substitute here. What do you get? Ka equal to, what do you write? C into lambda square upon lambda naught square upon 1 minus lambda by lambda naught. What you will write? Lambda naught minus lambda upon lambda naught. One lambda naught gets cancelled. Right? So what is Ka equal to? Yes, sir. Yes, sir. Go. What is Ka equal to? C lambda square upon lambda naught into lambda naught minus lambda. Correct, sir? Let's say something. Correct or not? Now see that same equation whether they gave or not. Whether they have given same equation or not. Let's see alpha square by 1 minus alpha. We took LCM also. Clear? Same thing. Now again numericals. Conductometric titrations over or not? No. First 20% part is over. But I told you totally this chapter possesses 5 parts. What are they? Conductance and conductivity, electrolytic cell, electrochemical cell, batteries, corrosion, in which first part is over. Clear? Now come to next questions. This is on conductance only, yeah? Electricity, conductance of water. This is based upon conductance. This is only one question related to conductance, man. This is first law. This is also first law. We will solve question number 6 alone. Solve this question. Solve it,
Sir,
sir.
what is page number of this?
What is that page number? 121. Meanwhile, I will check for other questions. All you 7 people are making noise. Section 1, I will not solve anything. Directly, I will go to section 2. Section 2, star mark questions I am taking. First question number 3. I think we solved that question number 3. Solved or not? Huh? Question number 3 solved or not? Question number 3. Here, already done. Then question number 4, 5, 6, 7. Now we will see question number 7. Paste question. If we weak monobasic acid means acid which can give only 1 H plus is titrated with NaOH, means weak acid versus strong base. How the graph is? Strong. That is also. Up to here they gave. After equivalence point, it rises further, na? Where is that? Say something, man. Now, first we are taking weak acid. Weak acid will not ionize perfectly. So actual graph must be. How actual graph will be? First, it will increase up to certain extent. After that, increases more. This is how the graph look like. Or say something, yes or no? So anyhow, answer we are going for this because they have not crossed equivalence point. That is the meaning of it, correct? If you cross equivalence point, slope of the line should change. Only 2 star mark questions are. See? Then I will go to next section, previous JE questions. In that any star? Question number 49. Question number 49 is having star. Huh? Easy, huh? What is it, sir? Unit, cell constant, L by A. So, per meter. So, A is 3. Then, molar conductivity, Simon centimeter square per mole. So, 1. Conductivity, ohm inverse, meter inverse. Degree of dissociation alpha, no dimensions. Right? Next. Question number 52. That is also waste question. Benzoic acid versus NaOH. How the graph? First option. I am not solving it. Or I will do one thing. I will delete this. Instead of question number 7, we will keep question number 52. Because question number 7 and this both are same only. Now the correct answer. Then 53, 54, 55, 56. Question number 56. I don't like these questions, man. This is also waste question only. What is the answer, sir? Because Na plus incorrect they want. Okay. Incorrect means third option is incorrect. Now you check for good question. All these questions are nonsense only. Question number 85, sir. All this. Solve this one. KCl solution of conductivity 0.14 Simon per meter shows a resistance of 4.19 ohm. In a conductivity cell, if the same cell is filled with an HCl solution, resistance drop to 1.03 ohm. The conductivity of HCl solution is. Sorry. Meanwhile, I will search for another question. Yes. Question number 87. 86. Yes. Question number 86. Question number 86 I will solve. Meanwhile, you solve that question number 85. All these questions are reasonably good, ma'am. Previous JE questions. Solve, ma'am. 85. 86 I will solve. Hey, direct formula only now. Huh? You are getting 57. Huh? Is there any difficulty? Answer is not given as 57. Huh? Then over. Direct formula only. You want 85, huh? This answer you are saying. Array, see this, what they are saying. KCl solution have conductivity. Kappa is given, man. Kappa is 0.1471 per meter. Resistance R equal to 4.19 ohm. If the same cell is filled with HCl, resistance drop with. This is in case of KCl solution. Now, if you take HCl aqueous, now resistance is given as 1.03 ohm. Then what is kappa equal to? What do you write? What is the formula, sir? Kappa equal to 1 upon R into L upon A. What is kappa here? 0.14 equal to 1 upon 4.19 into L upon A. As you are using same cell, what happens to L by A? Substitute this L by A value here, right? So what do you write? Kappa equal to 1 upon 1.03 into what is L by A? 0.14 into 4.19. Problem solved. Right? What is that value? 57 into 10 power minus 2. 0.14 into 4.19 divided by 1.03. 56.95 into 10 power minus 2. Come to next question. Now what they are saying? Resistance of conductivity cell. First they have given KCl again. In this KCl solution, what they give? L by A is given 129 per meter. Cell constant and filled with 74.5 means concentration of this HCl aqueous is 74.5 ppm. Correct? And resistance R equal to 100 ohm. Now when the same cell is filled with, now KCl aqueous equal to 149 ppm. Resistance R equal to, what is resistance R? 50 ohm. Now what they want? Here it is lambda 1 molar conductance. Here molar conductance is lambda 2. You want lambda 1 upon lambda 2. How to find lambda? Kappa into 1000 by molarity. Correct? Instead of molarity, I am directly substituting ppm. Reason? ppm gets cancelled now when I take ratio. Correct? So is equal to what is kappa? 1 upon R into, better I will write that formula here. Lambda equal to, what is kappa? 1 upon R into L by A into 1000 upon concentration of solution. Right? Whatever they have given, I will substitute because you want ratio only. Right? Or I will write divided by normality because I have taken equivalent conductance. Clear? Now what is that value? Directly I am taking ratio, man. 1 upon 100 L by A 129 into 1000 upon what is concentration? 74.5 divided by 1 by 50 into cell constant remains the same 129 into 1000 upon waste question. Waste or not? What is the value? But they gave that value as into 10 power minus 3. They gave that value as x into 10 power minus 3. What is the value of x? 1000. Check the answer. Check the answer. Over. Right? Next question, sir. They have given something in KSP, sir. We will solve that also. Question number 88. Solve this one. Something they gave in terms of KSP. 10 power minus 5 molar AgNO3 is added to 1 liter of saturated solution of AgBr. Conductivity of the solution is KSP of AgBr is given, lambda naught of Ag plus Br minus NO3 minus everything is given. Solve. Solve. Online. Anyone awake?
Yes, sir.
Vasumati, last class you are absent. This is the first class you are attending, huh? Left. Vasumati left.
No, sir.
No, huh? This is the first class. Okay. Then Yalini, she came, she also came. Vishandi is coming, Shivaganesh, Sai Vishagan. Sai Vishagan, are you coming regularly? Ritika,
Yes, sir.
are you coming regularly to classes?
Yes, sir.
Okay, Pranavji, all these people are okay. Akhilesh, Nitin Pandi, Jeevatharan, okay, these people are here only. Aditya is here. Huh? Hey, where is your ID card? How you got your ID card? Who gave you? Huh? You forgot, no? How you got that bag? You haven't forgot, huh? Sunday, someone is searching for you. Hey, do you remember? Last Sunday, any of you are here? Someone came and searching for him or not? Huh? From home, right? Arey, his father came to branch and gave the ID card, correct? Sunday. Yes, man. Evidence is there. Saying that my son is in branch. He only know. That madam also came twice or thrice asking him. Madam only. No, not your. Madam came to class. Why madam came to class means your father came to branch, gave the ID card, saying that my son forgot this ID card at home. Hey, Aditya K, correct name? Aditya K. I don't know. I don't know. Proof. If you come to weekend class, I will show at least 70 members as proof. We searched for you throughout building. We are unable to find you. Naughty fellow. Huh? On Sunday, where you are? We don't know, man. Arey, correct or not? I am not joking, really. One madam came to class searching for you with your ID card, saying that your father came to office, gave this ID card. Please give this ID card to Aditya K. She took that ID card, came to class. I told he is not here. He is weekday. She went. Again, after 10 minutes, she came back again. Sir. His father gave this ID card saying that he is inside the building. I gone out, giving break for 5 minutes. Went, I searched every room. I am unable to find. Then came to class and I announced in class, this naughty fellow started from home, not reached Akash. This is what happened. This is fact. Later, maybe your father took that ID card and gone home again. And he has not said anything to you. See. Huh? He knows everything. But he is acting smartly. He is waiting for your answer. You need to answer to him. Go home, confess to your father. What you have done on Sunday, confess. What, man? I don't know. I don't know yet. Hey, this is happened. Proof I will show. Any other student on weekend? Are any one of you came on weekend? Online? Last Sunday. If anyone is there, I will show the proof. He came. That's why he is the proof. If you coming Sunday, Saturday, if you come to class, I will show 70 students as proof. Right. Solved? Huh? This question done? Or any other Aditya K is available? I don't. You have done something. That is for sure. That maybe another little Aditya K is roaming in. Hey, take positively, man. Nah? Don't feel bad. Right, come to this. So read this question carefully, sir. Please. They gave lambda naught values. And what they are saying, you are adding 10 power minus 4 molar AgNO3 to a saturated solution of AgBr. Solution is saturated means concentrate KSP equal to concentration of Ag plus into concentration of Br minus, correct? Or if KSP equal to KIP, then it is called saturated solution, correct or not? Or a product of concentration of ions is equal to KSP means saturated. If KIP becomes greater than KSP, super saturated. Or ions concentration is more than what should be. Then it is called KIP greater than KSP. Then precipitation occurs. If KSP is less than KIP, okay, same only, man. KSP less than KIP or KIP greater than KSP. Huh? If KSP greater than KIP, unsaturated. Right? Better I will write it. If KSP greater than KIP, then unsaturated. Hey, stop that. Don't tease him. If KSP less than KIP, precipitation occurs. Supersaturated solution, that's why precipitation occurs. Right? Now they gave saturated solution, means product of concentrations of these two must be equal to KSP. What is KSP value? What is KSP value? So 4.9 into 10 power minus 13 equal to, what is concentration of Ag plus? What is concentration of Ag plus? You are adding na AgNO3. So what is concentration of Ag plus? 10 power minus 5. Respond. What is concentration of Br minus now? We got it? We got concentration of Br minus or not? Now what is it? 4.9 into 10 power minus 8. Right? What is concentration of Ag plus in the solution? 10 power minus 5 only. Right? Now, what is concentration of NO3 minus? That is also 10 power minus 5 only, na? We are adding AgNO3, man. AgNO3 dissolves in water to produce 10 power minus 5 moles of Ag plus, 10 power minus 5 moles of NO3 minus. That's what I wrote, NO3 minus Ag plus. Right? What is concentration of Br minus? Concentration of Br minus. By using KSP equal to this, I calculated concentration of Br. Right? Definitely Ag plus value is slightly more than this. Because it is saturated solution, na? It is slightly more than this. When compared to that, that value becomes negligible. Clear? Response, sir. Now, lambda naught values are given. Now, what is conductivity of that solution? What is conductivity? Lambda equal to kappa into 1000 by concentration. Correct? So what is conductivity? Conductivity of Ag plus plus conductivity of Br minus plus conductivity of NO3 minus. If I add, then you will get total conductivity. Correct? So, series. Lambda equal to, can I write kappa into 1000 by molarity? Right? Now I know concentration of Br minus and I know lambda of Br minus. From that, what you will get? Kappa of Br minus I will get. Say something. So what is kappa of Br minus equal to? Lambda of Br minus into molarity upon 1000. If it is per liter, say something. If it is not per liter, if it is for the total solution given, I will not write this 1000. Or if it is for 1 liter, I will write 1000. If it is for the total solution given, I will not write 1000. Na? So what is kappa of Br minus? Lambda of Br minus into concentration of Br minus. Correct? So what is kappa of this total solution? Equal to kappa of Br minus plus Ag plus plus NO3 minus. So what is Br minus value? Br minus value 8 into 10 power minus 3 into 4.9 into 10 power minus 8. Accepted or not? Or lambda into m plus Ag plus value 6 into 10 power minus 3 into 10 power minus 5 plus NO3 minus 7 into 10 power minus 3 into 10 power minus 5 equal to 4.9 into 8. 4.9 into 8. 76, huh? 7. 39. 39.6. Can I write that 39.6 as? Oh, 72. Okay. 39.2. Can I write that as 0.0392 into 10 power minus 8. 0.039.2, na? 10 power minus 3 is there. So I have to move that 3 positions. So 0.0392 into 10 power minus 8 plus 6 into 10 power minus 8 plus 7 into 10 power minus 8. Response, sir. What is the total value? 13.0392 into 10 power minus 8. So you want nearest answer or exact answer? They have not mentioned anything. So I will write exact answer. What is it? 13.0392. Or I will write the answer as 13. What they give? What they give? Hey, why man? Oh, per liter they ask. Oh, array. See the question. In question they give 1 liter again. What I told? For the total solution. If it is per liter, what I have to do? This 1000 should be there, na? If it is per liter, I need to take 1000. Then what happens to this equation? Divided by, hey, divided by 1000, man.
Sir, unit is Simon meter square, no, sir. Then 1000 should come now.
This becomes 10 power minus 3. Why? See the units. It is not centimeter square. Meter square, na? Simon meter square per mole means what is lambda? Kappa into 10 power minus 3 by molarity. Correct? If it is Simon centimeter square per mole means kappa into 1000 by molarity. So if it is 10 power minus 3 by molarity, what you will get? Into 1000, huh? Response, sir. So this whole thing into 10 cube. Then what is the answer? 13,039.2. That should be the answer. Clear? Any questions, sir? I am writing again, sir. Lambda equal to kappa into 1000 by molarity. Then its units is Simon centimeter square per mole. Or I will write lambda equal to kappa into 10 power minus 3 by molarity. If its units are Simon meter square per mole. Correct? Any questions further? Say something. Now let us go for another question. This is okay. Kohlrausch law. Just if you add, it is over. Question number 90, sir. Solve this one. Solve this one, sir. Meanwhile, I will take attendance. Offline 16 students present. Offline 4, 7, 10, 11, 14, 16, 17, 18, 19, 20, 21. Array, 22 people are present, man. Okay, I will take that attendance. Online, I will give. What is the formula, sir? Alpha equal to. Waste question, man. Alpha equal to. Lambda by lambda naught. Right? What do you want? Ka. First you find alpha. Already you know that Ka equal to C alpha square upon 1 minus alpha over. So what is Ka equal to? Concentration, how much they gave? 10 power minus 3, right? Into lambda by lambda naught square. What is lambda? They gave conductivity. So we need to find first lambda. So what is lambda equal to? Kappa into 1000 by molarity, which is equal to kappa is given as 2 into 10 power minus 5. See the units, Simon per centimeter, right? Into 1000 by what is molarity given? 10 power minus 3. So this is equal to, this becomes 10 power 6, right? So 20. Correct? So lambda is 20, lambda naught 190 square upon 1 minus 20 upon 190. This is K. Let's say something, correct or not? Find that value. So 10 power minus 3 into 4 upon 19 into 19 divided by what you will write here? 19 minus 2. 17 upon 19. Can I cancel 119 term? So this is equal to what you will get? 4 upon 19 into 17 into 10 power minus 3. Correct? Find that value.
12.3 is what is 12.3 10 to the power minus 6.
So we got this value as 12.3839 into 10 power minus 6. So nearest integer. What is nearest integer? 12 only, na? Response, sir. Correct? Okay, sir. For today, I will end the session. In next class, what we will see? Hey, say something. What we need to see in next class? Electrolytic cells. So conductance and conductivity, complete discussion is over. Right? All types we have discussed. Right, sir? Online students, you are free to leave.
Thank you, sir.
Thank
I
you,
will end
sir.
the session. Yes, madam. Bye. Bye, sir.
Thank you, sir. Thank you,
Right,
sir.
sir.
Thank you, sir.